Hello learners, welcome to Sure Question Academy. Please watch the videos, like and subscribe to the channel.
Hello. Welcome to today's physics session. Today, we are going to master a very important exam topic, electric power and resistivity. Grab your notebook and let's decode this step by step. Let's start with Part A, Section 1. The question asks us to define electric power and express it using potential difference and resistance. So, what exactly is electric power? Think of it like how fast a device uses electricity. Formally, it's the rate at which electrical energy is dissipated or consumed in a circuit. It can be represented by the formula. Power P equals current I multiplied by voltage V. Let's quickly review the units. P is the electric power in watts. I is the current in amperes. And V is the potential difference measured in volts. We can also express this using Ohm's law. By substituting I with V over R, power can also be written as power P equals voltage squared divided by resistance R. Or, if we substitute V instead, P equals current squared multiplied by resistance. Memorize these three forms. Now, let's put this into practice with a real-world example in Section 2. Imagine an electric oven connected to a 220-volt mains supply. It consumes 11 units of energy over a 5-hour baking session. From this, we need to calculate the power rating of the oven, the current drawn by the oven, and the resistance of the oven when it is red hot. Let's tackle Part A first, finding the power rating. Since we already have total energy and time, we use the basic definition of power. Power P equals total energy consumed, E, divided by the time taken, T. Here, our energy E is 11 units, which is exactly 11 kilowatt-hours, and time T is 5 hours. Plugging those values into our equation, power equals 11 kilowatt-hours divided by 5 hours. When we divide 11 by 5, we get exactly 2.2 kilowatts. To make our next steps easier, let's convert this to regular watts. That's 2200 watts. Awesome. Now for Part B, finding the current drawn by this oven. The formula relating power, current and voltage is P equals IV. To find the current, we just rearrange it by moving voltage to the other side. So, current I equals power P divided by voltage V. Let's substitute the values we just found. Our power is 2200 watts divided by the mains voltage of 220 volts. 2200 divided by 220 is a nice, clean calculation, giving us exactly 10 amperes. That's a fairly high current, which is why ovens need thick wires. Moving on to Part C. We need the resistance of the oven when it's red hot and working. We can use the formula linking power, current, and resistance, P equals I squared R. Rearranging this formula to solve for resistance gives us resistance R equals power P divided by current squared. Let's plug in the numbers we know. Power is 2200 divided by our current of 10 squared. 10 squared is just 100. So, 2200 divided by 100 gives us exactly 22 ohms. You are doing fantastic. Let's keep this momentum going. Now, let's look at the alternative or section of the exam paper. Part B, question 1 asks for the mathematical relationship between resistance and electrical resistivity. And then, it asks us to derive the C unit of electrical resistivity. Let's start with the relation. Think of an electrical wire like a water pipe. The longer the pipe, the harder it is for water to flow. The wider it is, the easier. Similarly, resistance is directly proportional to length and inversely proportional to cross-sectional area. So, the resistance of a conductor is given by the formula. Resistance R equals resistivity ρ multiplied by length divided by area. Here, the Greek letter ρ represents electrical resistivity. This is a characteristic constant that depends entirely on the material itself, like copper versus aluminum. To derive the C unit of this resistivity, let's rearrange our formula to isolate ρ. Multiplying both sides by area and dividing by length, ρ equals resistance times area over length. Now, let's substitute the standard C units for each of these physical quantities. The unit of ρ equals ohms for resistance multiplied by square meters for area, all divided by meters for length. One of the meters cancels out from the top and bottom, leaving us with ohm meter. Always double check this unit. It's a huge favorite for board exams. Let's put this formula to the test with sub-question 2. We have a metal wire 3 meters long with a resistance of 60 ohms. If the area of cross-section is a tiny 4 times 10 to the minus 6 square meters, calculate its resistivity. Let's calculate. Always list your given values first to avoid mistakes. Resistance R is 60, length L is 3, and area A is 4 times 10 to the power of minus 6. Using the formula we just rearranged, ρ equals resistance times area divided by length. Substituting our numbers into the equation, we get 60 multiplied by 4 times 10 to the minus 6, all divided by 3. 60 divided by 3 is 20. And 20 times 4 is 80. Adjusting the decimal place for standard scientific notation gives us a final resistivity of 8 times 10 to the power of minus 5 ohmmeters. Finally, sub-question 3 poses a tricky conceptual scenario. If we take this exact wire and stretch it so its length is doubled, what happens to its resistivity? And justify your answer. Let's see the effect of stretching. Here is the trick that catches many students. The electrical resistivity remains absolutely constant. It does not change at all. Why? Because resistivity is a characteristic property of a material. It's like the DNA of the metal. It only depends on the nature of the material itself and its temperature. It does not care about physical shape or size. Stretching it, bending it, or cutting it changes its resistance, but never its resistivity. Excellent. You've just mastered some of the most critical concepts in electricity. Keep reviewing, stay curious, and happy learning.